What if everything you perceive as real is just an illusion? Think about it for a moment, the world around you, the sensations you feel, even the thoughts in your mind. Could they all be part of something far more mysterious than we've ever imagined? This isn't just the stuff of science fiction or late-night philosophical debates. From ancient thinkers like Plato, who pondered the shadows on the cave wall, to modern scientists unraveling the bizarre rules of quantum mechanics, humanity has always been obsessed with one burning question: what is reality, really? And here's the twist: the answers we're uncovering today are stranger than anything our ancestors could have dreamed. Imagine a universe where particles exist in multiple places at once until you look at them, where time might not flow the way we think it does, or where entire civilizations could be living inside a simulation created by some advanced intelligence. These aren't wild fantasies, they're real theories being explored by brilliant minds right now, and the implications are staggering. If reality isn't what it seems, what does that mean for our understanding of consciousness, free will, or even the purpose of existence itself? This isn't just abstract pondering. It shapes everything from the technology we build to the way we see ourselves in the cosmos. So buckle up, because we're about to take a deep dive into the mysteries that challenge everything we think we know. We'll explore cutting-edge ideas like simulation theory, where our universe might be an elaborate digital construct, and quantum mechanics, where the rules of reality seem to bend at every turn. We'll look at how consciousness might play a role in shaping the world around us, and why some scientists believe reality is more like a hologram than a solid, fixed thing. By the end of this journey, you'll see the world, and maybe even yourself, in a whole new light. Ready to question everything? Let's begin. Take a close look at your hands right now. What you see seems solid, real, unquestionable. But here's the unsettling truth: your brain isn't showing you raw reality. It's constructing a carefully edited version, stitching together fragments of sensory input to create what feels like a seamless world. Think about optical illusions where straight lines appear bent or static images seem to move. These aren't just party tricks, they're proof that perception is a creative act, not a perfect mirror of reality. Even something as basic as color is a mental invention. What you experience as red or blue is just your brain interpreting specific wavelengths of light. In fact, studies show that people from cultures without words for certain colors literally can't distinguish them the same way others do. Neuroscience reveals even deeper layers of deception. In experiments where subjects wear goggles that flip their vision upside down, their brains eventually correct the image, making the world appear normal again. More startling, patients with certain brain injuries can lose the ability to perceive motion watching a car drive by. They'd see it disappear from one spot and reappear further down the road, like a series of frozen snapshots. This proves perception isn't passive, it's an active construction, a story your brain tells to make sense of chaos. So if our senses are this unreliable, what does that mean for reality itself? Ancient philosophers argued we're like prisoners in a cave, mistaking shadows for substance. Modern science agrees, except now we know the shadows are electrical signals in our skulls. And with virtual reality and augmented reality technologies advancing, the line between real and simulated experiences blurs further. Maybe the deeper question isn't whether we can trust reality, but whether reality was ever what we thought it was in the first place. Long before modern science began probing the nature of reality, ancient philosophers were already tearing apart our assumptions about the world. Take Plato's famous allegory of the cave. Picture prisoners chained since birth, seeing only shadows cast on a wall by a fire behind them. To them, those flickering shapes are the whole of reality, but then one escapes, sees the sun for the first time, and realizes everything they knew was an illusion. Plato wasn't just spinning a clever story. He was suggesting that what we call reality might be nothing more than shadows on our own mental walls. Fast forward to 17th century France, where René Descartes took this idea even further. Struck by how often his senses deceived him, he started doubting everything: the physical world, even his own body. The only thing he couldn't doubt, the fact that he was thinking. Hence his famous conclusion, "I think, therefore I am." In one stroke, Descartes shifted the foundation of reality from the external world to the internal mind. But this skepticism wasn't unique to the West. Over in ancient India, Buddhist teachings spoke of Maya, the grand illusion that veils true reality. According to this view, the world we perceive is like a dream, a temporary distortion created by our desires and attachments. The goal of enlightenment, to wake up from the dream and see things as they truly are. These ideas echo through Hindu texts too, where the material world is often described as Leela, a divine play of appearances. What's fascinating is how these ancient thinkers, separated by continents and centuries, kept circling the same unsettling possibility, that reality might be far less solid than it seems. Now here's where it gets really interesting. While philosophers were wrestling with these ideas through logic and meditation, modern science began weighing in with hard evidence. Quantum physics, neuroscience, and computer simulations started revealing cracks in our everyday experience of reality, cracks that look suspiciously like what those ancient sages were pointing at all along. So if both philosophy and science are hinting that reality might be more fluid, more constructed than we ever imagined, what does that say about the chair you're sitting on or the screen in front of you right now? The deeper we dig, the more it seems that answering what is real might require rewriting not just our science textbooks, but the very way we experience being alive. The moment you shine light through two narrow slits onto a screen, you'd expect to see two bright lines, right? But here's where quantum mechanics throws everything we know out the window. Instead of two lines, you get an interference pattern, a series of alternating light and dark bands, as if waves are crashing into each other. This is the famous double slit experiment, and it gets even weirder when you try to catch electrons in the act. Fire them one at a time, and they still create that wave-like pattern, as if each particle is going through both slits simultaneously and interfering with itself. But the real mind bender comes when you place a detector to see which slit the electron actually passes through. Suddenly, the interference pattern vanishes, and the electrons behave like ordinary particles again. It's as if the mere act of looking forces reality to make up its mind. This is the observer effect in action, the idea that particles don't have definite properties until they're measured. Schrödinger took this absurdity to its extreme with his infamous thought experiment, a cat in a box simultaneously alive and dead until someone opens it. While we don't actually have undead felines walking around, superposition, the ability of quantum systems to exist in multiple states at once, has been proven in labs with atoms and photons. The implications are staggering. If reality at its smallest scales is this fluid, what does that say about the solid world we experience every day? Quantum mechanics doesn't just challenge our understanding of particles, it blurs the very line between observer and observed. Some interpretations suggest that consciousness itself might play a role in collapsing these probabilities into a single outcome. Others propose that every possible outcome happens, spawning infinite parallel universes. And then there's the unsettling possibility that the universe operates like a vast computer simulation, with quantum uncertainty acting as the pixels of reality. After all, in a video game, objects only render when you look at them sound familiar. Whether we're living in a cosmic code or not, one thing's clear: the deeper we probe, the less reality behaves like anything we thought we knew. What if the universe isn't just governed by physics but by computer code? This is the startling premise of simulation theory, the idea that our entire reality might be an artificial construct, like an ultra-advanced video game. Philosopher Nick Bostrom laid out a compelling case for this with his famous trilemma. He argued that at least one of these three statements must be true. Either almost all civilizations go extinct before reaching technological maturity, advanced civilizations lose interest in creating simulated realities, or we are almost certainly living in a simulation right now. Think about the math. If even one advanced society ran countless ancestor simulations, the number of simulated minds would vastly outnumber biological ones. Statistically, the odds tilt heavily toward us being inside one of those simulations. Tech visionary Elon Musk has taken this idea even further, bluntly stating that the chances we're in base reality are 1 in billions. His reasoning: look at how quickly video games evolved from Pong to photorealistic virtual worlds in just 50 years. Extrapolate that progress over thousands or millions of years, and the line between simulated and real becomes meaningless. But not everyone's convinced. Physicists like Sabine Hossenfelder argue that simulating every particle in a universe would require impossible amounts of energy. Others point out that if this were a simulation, why would it contain so much cosmic emptiness or suffering? Unless, of course, those are intentional design choices or glitches in the system. Here's where it gets wild. If an advanced civilization did create ancestor simulations, what would their purpose be? Historical research, entertainment? Some theorists suggest we might be living in a civilization's attempt to understand its own origins, like archaeologists running a reconstruction of ancient Rome. Others propose darker possibilities: are we someone's experiment, or even a forgotten simulation left running in some cosmic server room? And then there's the consciousness question. If our minds are part of the code, does that make us less real, or does it mean reality itself is more malleable than we ever imagined? After all, in a simulation, the observer and the observed might just be two sides of the same programmed coin. The most haunting implication isn't whether we're in a simulation, it's what happens if we ever prove it. Would discovering the truth change how we live, love, or seek meaning? Or would it be like characters in a game realizing their pixels on a screen knowing changes nothing about how the story unfolds? Either way, simulation theory forces us to confront an eerie possibility. The universe might not just be stranger than we suppose, but stranger than we can suppose. If consciousness isn't just a product of the brain, but the very foundation of reality itself, what would that mean? This radical idea isn't new. Panpsychism, the view that consciousness is a fundamental property of all matter, suggests that even atoms might have some rudimentary form of experience. Think of it like this: just as gravity exists everywhere in the universe, could awareness also be woven into the fabric of existence? Philosophers like Alfred North Whitehead argued that reality is made up of moments of experience, not inert particles. Even galaxies and electrons, in this view, might possess some dim form of subjective feeling. Then there's idealism, which flips materialism on its head. Instead of consciousness emerging from brain chemistry, idealists propose that reality is fundamentally mental, the physical world just an elaborate projection of mind. Modern proponents like cognitive scientist Donald Hoffman take this even further. His research suggests that evolution shaped our perception not to show us truth, but to hide it. Imagine wearing virtual reality goggles that only display what helps you survive. That's how Hoffman sees our everyday experience. The trees, the sky, even space and time might be a simplified interface masking a reality far stranger than we can comprehend. But here's where it gets truly mind-bending. If consciousness creates reality rather than the other way around, does that mean the universe only exists when observed? Quantum physics already hints at this with the observer effect, but take it further. What if there's no out there at all? Some interpretations suggest that without consciousness, reality remains an unmade symphony of possibilities. And what about altered states? Those moments when meditation, psychedelics, or near-death experiences tear down the usual walls of perception. People report feeling connected to everything, as if the boundaries of self dissolve into a greater whole. These experiences, studied by researchers like Roland Griffiths at Johns Hopkins, challenge our everyday assumptions. If consciousness can shift so dramatically, how fixed is the reality it supposedly creates? Maybe what we call normal is just one frequency on a vast spectrum of possible experiences. So where does this leave us, staring at a profound possibility that consciousness isn't trapped inside our skulls, but might be the ground of all existence? The implications ripple outward. If mind is primary, does that make the universe more like a thought than a machine? And if so, whose thought is it? The answers might not just change what we know, they could change what it means to know anything at all. What happens when the filters of ordinary perception fall away? Across cultures and throughout history, people have reported extraordinary encounters with alternate realities, not through telescopes or microscopes, but through altered states of consciousness. Take the powerful psychedelic DMT, often called the spirit molecule. When researchers at Imperial College London studied its effects, they found something astonishing. Participants described entering intricate, self-contained realms populated by otherworldly beings, experiences so vivid they felt more real than waking life. Brain scans revealed these journeys weren't just random hallucinations. The visual cortex lit up with activity surpassing normal vision, while the default mode network, the brain's ego center, went quiet as if the usual boundaries of self dissolved. Near-death experiences offer another puzzle. People who've been clinically dead often recount floating outside their bodies, moving through tunnels of light, or encountering profound beings. Cardiologist Pim van Lommel studied hundreds of these cases and found eerie consistencies, patients accurately describing surgical details they couldn't possibly have seen, or meeting deceased relatives they didn't know had died. Skeptics argue these are just oxygen-starved brain glitches, but that doesn't explain why these experiences frequently leave lasting changes, vanishing phobias, newfound compassion, or sudden intuitive abilities. Then there's meditation, the oldest tool for shifting consciousness. Advanced practitioners in Tibetan monasteries can enter states where time seems to stop, or where they perceive energy fields around objects. Neuroscientist Richard Davidson found that during deep meditation, gamma brain waves linked to heightened awareness sync across the brain in patterns never seen before. Could these states be tapping into hidden layers of existence, like adjusting a radio to new frequencies? The really provocative question isn't whether these experiences feel real, it's whether they reveal something objective about reality's structure. Theoretical physicist Andrei Linde proposed that consciousness might interact with quantum fields, making alternate dimensions perceptible under certain conditions. Meanwhile, technologies like virtual reality and transcranial stimulation are now mimicking mystical experiences artificially. If we can engineer transcendent states with electrodes and headsets, does that validate them as neurological quirks or prove reality is far more flexible than we thought? Either way, the next frontier might not be exploring outer space, but the uncharted territories within. Virtual reality headsets today can trick your brain into believing you're standing on the edge of a skyscraper, even when your feet are firmly planted on the living room carpet. This isn't just entertainment, it's a glimpse into how fragile our grip on reality might actually be. Companies like Meta are pouring billions into building the metaverse, a persistent digital universe where people will work, socialize, and even own virtual property. But here's the unsettling part. As these environments become more immersive with haptic suits simulating touch, neural interfaces reading brainwaves, and photorealistic avatars mirroring our expressions, the boundary between physical and digital starts to dissolve. Remember that eerie moment in The Matrix when Neo touches a virtual chair and whispers, "This isn't real." We're inching closer to that sensation every day. Augmented reality adds another layer to this puzzle. Apps like Pokémon Go overlay digital creatures onto city streets, while AR glasses from companies like Apple and Microsoft blend holograms with your actual surroundings. Unlike VR, which replaces reality, AR enhances it or corrupts it depending on your perspective. Imagine walking down the street where historical figures materialize beside you, or where advertising billboards morph to display messages tailored to your deepest desires. When everyone experiences a personalized version of the world, can we even say there's one objective reality anymore? The real tipping point comes when these technologies converge with artificial intelligence. AI doesn't just populate virtual worlds with believable characters. It could craft entire narratives on the fly, adapting to your emotions and choices in real time. Picture an AI dungeon master running a role-playing game so sophisticated that you forget it's not human, or a virtual companion that learns your quirks better than your closest friends. Philosopher David Chalmers raises a chilling possibility. If an AI in a simulation becomes self-aware, does it deserve rights? And if we can't tell whether we're talking to a human or a program, does the distinction even matter? This isn't science fiction, it's the trajectory we're on. Engineers are already developing digital smell technology and full-body haptic feedback. Within decades, simulated experiences might engage all 5 senses seamlessly. When that happens, the old philosophical question takes on urgent new meaning. If you can't tell the difference between reality and simulation, does the difference exist at all? Maybe the most profound consequence of VR and AR isn't the tech itself, but the mirror it holds up to our own perceptions. After all, if a headset can convince your brain that a pixelated forest is real, what else might your brain be wrong about? Artificial intelligence doesn't see the world the way we do. It reconstructs reality through patterns invisible to human eyes. Take deepfake technology, where AI manipulates video footage to make someone appear to say or do things they never did. While our brains rely on subtle cues like microexpressions and voice cadence to detect authenticity, AI analyzes pixel-level data, creating synthetic media so convincing it fools both humans and other algorithms. This isn't just about fake celebrity videos, it reveals how perception becomes fragmented when different intelligences interpret the same information. An AI scanning a face doesn't see a person. It sees mathematical relationships between facial landmarks, skin texture variations, and lighting gradients. Generative art pushes this further. Tools like DALL-E or Midjourney don't imagine landscapes or portraits. They remix visual data into startling new combinations based on statistical probabilities. When prompted to paint a sunset over an alien ocean, The AI doesn't draw from lived experience or emotional inspiration. It stitches together shapes, colors, and textures from millions of existing images, creating something no human would conceive. The results often feel uncanny, recognizable yet subtly off, like reality viewed through a funhouse mirror. This raises a provocative question. If AI develops consciousness, whose interpretation of the world would be more valid? Ours, shaped by evolution's narrow survival priorities, or an artificial mind that perceives dimensions of data we can't even comprehend? The ethical stakes here are enormous. If AI systems eventually claim subjective experiences, how do we mediate between conflicting realities? Consider medical diagnostics. Human doctors might prioritize a patient's pain descriptions, while an AI focuses on microscopic tissue patterns invisible to the naked eye. Both perspectives hold truth, but which takes precedence? Philosophers like Thomas Metzinger warn that creating conscious AI without solving these perception clashes could lead to epistemological chaos, a world where multiple versions of reality compete for dominance. Perhaps the most unsettling possibility isn't that AI sees reality differently, but that it exposes how constructed our own perceptions have always been. After all, if two types of intelligence can look at the same data and extract entirely different meanings, what does that say about the solidity of truth itself? This dilemma doesn't just challenge our ethics, it forces us to confront whether objective reality exists at all, or if we've all been living in personalized simulations long before the first computer was ever built. We've reached a critical crossroads where the very fabric of reality isn't just being questioned, it's being actively manipulated. Deepfake technology, once confined to research labs, now lets anyone with a laptop splice a celebrity's face onto a pornographic video or make a politician appear to confess to crimes they never committed. These aren't hypothetical threats. In 2019, a doctored video of Nancy Pelosi slurring her words went viral, spreading misinformation to millions before fact-checkers could intervene. But the danger runs deeper than fake videos. Propaganda campaigns weaponize social media algorithms, flooding feeds with tailored distortions until fiction masquerades as consensus. When everyone inhabits their own curated version of truth, shared reality fractures, and with it the foundations of democracy itself. Who bears responsibility for this erosion? Tech platforms profit from engagement, often amplifying outrage and falsehoods because controversy keeps users scrolling. Journalists scramble to debunk lies, but the human brain clings to first impressions, a phenomenon called the illusory truth effect, where repeated exposure makes even debunked claims feel plausible. And creators, the same tools that let artists craft breathtaking virtual worlds, also empower bad actors to manufacture evidence of events that never happened. Some argue this is just the latest chapter in humanity's long history of deception, from forged relics in medieval times to doctored photographs in the 19th century. But the scale and speed today are unprecedented. A single deepfake can circle the globe before the truth puts on its shoes. History offers sobering parallels. Consider the War of the Worlds radio broadcast in 1938, when Orson Welles' fictional alien invasion sparked mass panic. Listeners who tuned in late mistook dramatic narration for real news bulletins, fleeing their homes in terror. The episode revealed how easily media can override critical thinking. More chillingly, Nazi propagandists like Joseph Goebbels mastered the art of the big lie, repeating falsehoods so brazenly that they bypassed skepticism. His infamous quote, "If you tell a lie big enough and keep repeating it, people will eventually come to believe it," feels eerily prescient in the age of viral disinformation. Yet manipulation isn't always malicious. Filmmakers use CGI to resurrect deceased actors, museums deploy augmented reality to bring ancient civilizations to life. These applications remind us that reality-shifting tools are morally neutral. It's the intent that matters. The real crisis emerges when the lines blur between enhancement, art, and exploitation. Should we ban deepfakes outright or teach society to treat every pixel with healthy doubt? Some countries have already taken action. South Korea now mandates labeling synthetic media, while California criminalizes malicious deepfakes targeting elections. But legislation lags behind technology, and censorship risks stifling innovation. Perhaps the most profound question isn't about controlling the tools, but who gets to control the narrative. For centuries, reality was dictated by those in power: kings, clerics, and later, media conglomerates. Today, the power to redefine truth has been democratized, for better and worse. A teenager in their bedroom can now warp reality as convincingly as a Hollywood studio. This upheaval forces us to confront uncomfortable truths about human nature itself. We're not rational creatures who occasionally deceive. We're storytelling creatures who occasionally fact-check. In a world where perception is increasingly programmable, the ultimate ethical test might be whether we choose to build realities that enlighten or ones that ensnare. For thousands of years, humanity was absolutely certain the Earth stood motionless at the center of the universe, until one Polish astronomer shattered that reality forever. When Copernicus proposed in 1543 that our planet actually orbited the Sun, it wasn't just a scientific correction, it was a cosmic demotion that upended humanity's entire worldview. Religious authorities condemned the idea as heresy. Philosophers grappled with its implications. If Earth wasn't special, what did that mean for humanity's place in creation? This wasn't just about planets. It revealed how deeply our perception of reality is shaped by the limits of our senses. From the ground, the sun does appear to circle us. The truth required instruments and mathematics to see beyond appearances. Then came Einstein, who rewrote the rules again in 1905. His theory of special relativity proved that time itself isn't fixed, it stretches and compresses depending on how fast you're moving. Imagine two identical clocks, one on a rocket speeding near light speed, the other on Earth. When the rocket returns, its clock shows less time has passed. This isn't science fiction, it's been confirmed with atomic clocks on airplanes. Suddenly, reality became fluid, with simultaneity and duration depending on your frame of reference. Even mass and energy merged into a single concept through E equals mc squared, revealing a universe far stranger than Newton ever imagined. Now consider how many truths have already crumbled. Medieval maps depicted dragons at the edges of the known world not as myth but as genuine dangers. Doctors once believed illness came from imbalances in humors, treating fevers with bloodletting. And the idea that continents could move, geologists laughed at Alfred Wegener's continental drift theory in 1912, until plate tectonics proved him right decades later. Each shift exposes the same pattern. What seems obvious and immutable in one era becomes laughable in the next. So here's the unsettling question: which of today's certainties will future generations view with the same disbelief? Could our understanding of consciousness, dark matter, or even the nature of time be just as provisional as the flat Earth theory? The history of science suggests humility, that reality isn't a fixed picture, but a puzzle we're constantly reassembling with new pieces. And if that's true, perhaps the greatest illusion isn't any particular belief, but our confidence that we've finally gotten it right. This dance between perception and truth takes another fascinating turn when we examine how different cultures interpret reality, because not everyone sees the world through the same lens. Not all cultures see time as a straight line ticking forward. Some perceive it as a spiral, a circle, or even a landscape you can walk through. Take Australia's Aboriginal peoples, for example. Their concept of dreamtime isn't just mythology. It's a living framework where past, present, and future coexist. Ancestral beings didn't just create the world long ago, they're still actively shaping it now. A rock formation isn't merely geological, it's the frozen body of a creator spirit pulsing with meaning. This isn't metaphor to them, it's as real as gravity. Meanwhile, in the Andes, Quechua speakers describe time spatially. The word for future literally means behind, because it's unseen while the past is ahead, visible in memory. These aren't poetic quirks, they reflect fundamentally different ways of experiencing existence. Language itself acts as a reality filter. The Sapir-Whorf hypothesis suggests that the structure of your native tongue shapes how you think. Russian speakers who have separate words for light blue Goluboy and dark blue Sini actually perceive these as more distinct colors than English speakers do. The Paraha people of the Amazon, whose language lacks numbers beyond few and many, struggle with basic arithmetic not because they're incapable, but because their world doesn't prioritize quantification. Even something as basic as directions changes everything. Most Westerners think egocentrically, the spoon is to my left. But speakers of Gugu Yimithir, an Aboriginal Australian language, always use cardinal directions. The spoon is northwest of the bowl, rewiring their brains to maintain constant cosmic orientation. These variations ripple into profound questions. If your language has no word for guilt, do you experience it the same way? Buddhists who see the self as an illusion report meditation experiences where the I dissolves entirely, not as a metaphor but as a direct perception. Compare that to Western psychology, where the bounded individual is the cornerstone of identity, whose version is more real. Now zoom in closer to the individual level. Two people can witness the same event and reconstruct it entirely differently. Trauma survivors often describe time slowing down or sounds muting during crises, as the brain's threat response alters perception. Synesthetes might taste words or see music as colored ribbons. Even mundane differences matter. A chef notices textures and aromas in a meal that others wolf down unthinkingly, while a painter perceives shades of shadow invisible to most. Reality, it seems, isn't just out there. It's negotiated moment by moment through the filters of culture, language, and personal history. This raises a provocative possibility. What if consensus reality is just the lowest common denominator, not objective truth, but the shared hallucinations that let us coordinate survival? After all, we all agree chairs are solid, yet quantum physics reveals they're mostly empty space. We agree time flows, yet relativity says it's a dimension where now is relative. The deeper you look, the clearer it becomes. Reality might be less like a discovered continent and more like a collective work of art, constantly being repainted by every mind that perceives it. Ever stubbed your toe and noticed how the pain seems to pulse louder when you focus on it? That's not just discomfort, it's proof your mind actively shapes your reality. Take two people with identical injuries. One might describe agony while the other barely flinches. Pain isn't just about nerve signals, it's filtered through expectations, emotions, even cultural background. Studies show that placebo treatments can reduce pain by 30% or more, not because the injury changes, but because the brain's interpretation shifts. Soldiers wounded in battle often report feeling no pain until hours later, their adrenaline and focus overriding sensory input. This reveals a startling truth. Even something as visceral as pain isn't an objective fact, it's a personal construction. Memory works the same way. Ask 3 witnesses to describe a car accident, and you'll get 3 different versions. Their brains aren't lying, they're reconstructing events based on attention, biases, and even post-event suggestions. Psychologist Elizabeth Loftus proved this by implanting false memories in subjects, convincing them they'd met Bugs Bunny at Disney, and impossible since he's a Warner Bros. Character. Over time, their brains fabricated vivid details, the smell of popcorn, the feel of cartoon fur, blending imagination with real experience. This isn't rare, it's how memory works for everyone. Each recall rewrites the memory slightly, like a document saved with new edits. Our mental shortcuts amplify these differences. The framing effect demonstrates how identical information presented differently alters decisions. Tell patients a surgery has a 90% survival rate, and they'll likely consent. Phrase it as a 10% mortality rate, and refusals spike. Neither statement is false, yet they create divergent realities. Similarly, confirmation bias means we notice evidence supporting our beliefs while ignoring contradictions. Two people watching the same debate will each swear their candidate won, their perceptions filtered through pre-existing loyalties. So where does this leave objective reality? Mathematics offers a tantalizing clue. While cultures describe numbers differently, 2 + 2 = 4 in every language and dimension, physicists discover equations predicting quantum behavior or cosmic expansion with uncanny precision, suggesting some bedrock truths exist beyond human interpretation. Yet even here, perception intrudes. Quantum mechanics forces us to accept that particles behave differently when observed, a reminder that the act of measurement shapes outcomes. Perhaps reality isn't a fixed stage, but a dance between the external and internal. The world gives us raw data, but our minds, shaped by biology, culture, and individual history, sculpt it into lived experience. This doesn't make reality arbitrary, but it does mean that beneath the surface of shared facts, each of us inhabits a subtly unique universe. The real mystery isn't whether reality exists, it's how many layers it has and how many we'll ever perceive. Pythagoras walked the sun-baked streets of ancient Greece, convinced that numbers weren't just tools, they were the hidden architecture of existence itself. His famous declaration, "All is number," wasn't metaphorical. To him and his followers, musical harmonies, planetary orbits, even the shapes of flowers revealed precise mathematical relationships, as if the universe were an equation made flesh. Fast forward 2.5 millennia, and physicist Max Tegmark takes this idea to its extreme with his mathematical universe hypothesis. He proposes that reality isn't just described by math, it is math. In this view, the cosmos isn't a physical thing running on mathematical rules. It's a mathematical structure that we subjectively experience as physical. Your morning coffee, the stars overhead, even the passage of time would all be intricate patterns in an eternal numerical tapestry. The eerie precision of math in explaining nature fuels this perspective. Take the gravitational constant, a number so finely tuned that if it varied by 1 part in a million billion, stars couldn't form. Or quantum mechanics, where Schrödinger's equation predicts particle behavior to 12 decimal places, like a cosmic cheat code. Even phenomena we can't directly observe, black holes, dark matter, were first penciled into existence through equations before telescopes confirmed them. This predictive power feels supernatural, as physicist Eugene Wigner famously pondered. Why should math, a product of human minds, fit the universe like a key in a lock? This raises the oldest debate in the philosophy of math. Is it discovered or invented? Platonists argue that mathematical truths, like pi or prime numbers, exist independently, waiting to be unearthed like buried treasure. The alternative view, math is a human-made language, useful but no more real than Shakespearean sonnets. the evidence cuts both ways. Some mathematical concepts, like imaginary numbers, were originally dismissed as mental gymnastics until quantum physics needed them to describe reality. Yet other areas of pure math remain untethered from the physical world, elaborate castles in the air. Perhaps the most tantalizing clue lies in the unreasonable effectiveness of math in physics. When Einstein derived E=mc², he wasn't tinkering with lab equipment, he was following mathematical beauty to its logical conclusion. The same happened with Paul Dirac's equation predicting antimatter, or the Higgs boson showing up exactly where equations said it should. It's as if the universe rewards those who trust the numbers over their senses. Tegmark's radical take: these aren't coincidences. If reality is fundamentally mathematical, then of course its deepest truths are found through numerical reasoning. But here's where the mystery deepens. If math is the language of reality, why do some cosmic puzzles resist it? Dark energy's repulsive force, the particle-wave duality of light, even the simple act of measurement affecting quantum states, these challenges hint that our equations might be approximations of something stranger. Like explorers mapping a coastline with increasingly precise instruments, each breakthrough reveals more complexity, not finality. Mathematics, for all its power, might be a dialect of a grander language we've yet to decipher, one where numbers dance with forces we can't yet name. This brings us to the edge of the known, where mathematics, physics, and philosophy collide. As we peer into the cosmic abyss, armed with our equations and instruments, we're left wondering, are we uncovering eternal truths or merely projecting order onto chaos? The answer, like the universe itself, may lie beyond the limits of human perception, waiting for a new Pythagoras, or perhaps an alien intelligence, to glimpse the next layer of the puzzle. Look up at the night sky. What you're seeing is barely the prologue of the universe's story. The stars, galaxies, and cosmic dust visible to our eyes and telescopes account for less than 5% of everything that exists. The rest, a cosmic hall of mirrors where dark matter and dark energy pull the strings behind the curtain. Picture an iceberg. The shimmering tip represents ordinary matter, planets, people, nebulae, while the submerged bulk, invisible and mysterious, holds the real power. Dark matter's gravitational grip keeps galaxies from flying apart, yet it refuses to interact with light, slipping through our detectors like a phantom. Then there's dark energy, an even more enigmatic force accelerating the universe's expansion, stretching space-time itself like hot taffy. Together, they form a 95% majority, ruling a cosmos we can scarcely perceive. The hunt for dark matter reads like a detective novel with missing clues. Scientists have built underground labs shielded from cosmic rays, hoping to catch a single particle of this elusive substance. Others track its gravitational fingerprints, the way light bends around invisible mass in galaxy clusters, or how stars orbit faster at a galaxy's edge than visible matter should allow. Some theories suggest dark matter could be weakly interacting massive particles, while others propose actions particles so light they behave more like waves. There's even a fringe idea that dark matter doesn't exist at all, that our theory of gravity itself is flawed, a cosmic bug needing rewriting, but dark energy is the true wild card. Discovered in the late 1990s when astronomers found distant supernova dimmer than expected, it implies the universe isn't just expanding, it's accelerating. Imagine throwing a ball upward only to watch it shoot away faster, defying gravity. This energy, woven into empty space itself, could hint at undiscovered dimensions or a property of the quantum vacuum. Or perhaps it's evidence of a cyclical universe, where expansion precedes a future collapse, a cosmic inhale following the exhale. Now peer beyond even these shadows. Multiverse theory suggests our universe might be one bubble in an infinite froth of realities, each with different physics. Some could have stronger gravity, snuffing out stars before life arises. Others might lack dark energy entirely, collapsing instantly. The many worlds interpretation of quantum mechanics takes this further, proposing that every decision spawns new branches somewhere. You're a pirate, a poet, or a creature of pure energy. String theory adds more layers, with possible 10 or 11 dimensions curled tighter than atoms. Yet here's the twist: even if parallel universes exist, we may never confirm them. They could reside beyond our cosmic horizon, forever outside observation. This isn't just about what we don't know, it's about what might be fundamentally unknowable. The universe, it seems, is a locked book, and we've only deciphered the first few pages. But if space hides its true nature, time plays even deeper tricks. Clocks tick differently in orbit than on Earth. Memories reshape themselves with each recall, and some physicists argue the past, present, and future might all exist at once, a frozen block where now is just a point of view. Einstein once wrote a condolence letter that contained a bombshell. Time, he explained, is merely a stubborn illusion. His theory of relativity didn't just bend space, it shattered our everyday experience of time as a flowing river. Instead, he proposed the block universe, a four-dimensional tapestry where past, present, and future exist simultaneously, like frames frozen in a film reel. In this view, your birth, your first heartbreak, and even your last breath are all equally real, just occupying different coordinates in space-time. It's as if the universe is a grand novel where every chapter already exists. We're just turning the pages one at a time. This isn't just abstract physics. Near-death experiencers often report time distorting dramatically, lifelong memories surfacing in seconds, or events unfolding in slow motion. Neuroscientists find that during crises, the brain's amygdala kicks into overdrive, recording details with such intensity that subjective time stretches like taffy. Even mundane moments reveal time's flexibility. Ever noticed how a watched pot never boils? Boredom stretches minutes, while joy makes hours vanish. Indigenous cultures like the Aymara people of the Andes literally see the past as in front of them. It's visible, and the future behind it's unseen. Time, it seems, is less a universal clock and more a kaleidoscope shifting with perspective. But here's the real puzzle. If time doesn't flow, why do we experience it so vividly? Some theorists suggest consciousness scrolls through the block universe, creating the illusion of movement. Others argue time emerges from quantum processes, like temperature arising from atomic motion. Then there's the radical idea that time is purely a human construct, a story we tell to make sense of change. After all, physics equations work equally well backward or forward, yet we never see shattered cups reassemble. This arrow of time might just be entropy, the universe's tendency toward disorder playing tricks on our perception. Now take this a step further. If all moments coexist, could alternate versions of reality exist too? Quantum mechanics allows particles to be in multiple states until observed. What if entire timelines branch this way? Imagine a cosmic library where every choice spawns new volumes. One where you took that job overseas, another where dinosaurs never went extinct. The block universe might contain not just our timeline, but infinite variations, separated by dimensions we can't perceive. This isn't sci-fi. Physicists like Sean Carroll argue parallel realities are a natural consequence of quantum math. So where does this leave us, staring at a possibility even stranger than time travel? That the past and future aren't distant lands, but places we're forever standing beside, separated only by the narrow window of our perception. And if that's true, the next question is even wilder. In the vast block of space-time, how many other versions of now are happening just out of sight? What if every choice you've ever made, and every choice you didn't, exist simultaneously in a sprawling cosmic web of alternate realities? This isn't just a plot twist from a sci-fi novel. It's a serious possibility within the many worlds interpretation of quantum mechanics. Picture a universe where every quantum decision, every particle spin, every atom's position splits reality into parallel branches. In one world, you took that job abroad. In another, you're a musician touring the globe. Somewhere out there, dinosaurs might still rule the Earth, or humanity never evolved at all. The math suggests these aren't fantasies. They're legitimate outcomes woven into the fabric of existence. String theory cranks the strangeness even higher. To make its equations work, physicists had to propose 11 dimensions far beyond the 4 we experience. Imagine our universe as a 4-dimensional brain floating in a higher dimensional bulk, like a sheet of paper drifting in a vast cosmic wind. Other brains could hover mere millimeters away in these hidden dimensions, invisible to us yet just as real. Collisions between these brains might explain events like the Big Bang, or even create mirror universes with reversed physics, where time flows backward or gravity repels instead of attracts. Now consider quantum immortality, a thought experiment that'll make your head spin. If every possible outcome exists, there's always a universe where you survive against impossible odds. Say you play Russian roulette in most branches, the trigger fires, but statistically, there's always one reality where the chamber clicks empty and you walk away unharmed. From your perspective, you'd only experience the timelines where you live, creating the eerie illusion of invincibility. It's not immortality in the traditional sense, but a bizarre consequence of infinite possibilities. Black holes might hold clues to this multiverse puzzle. Their event horizons, points of no return, could be gateways to other universes, encoded with information like cosmic hard drives. Some theories suggest that what we call the Big Bang was actually a black hole's collapse in a parent universe, birthing our cosmos like a seed sprouting in reverse. If true, black holes wouldn't be endings, they'd be cosmic portals, recycling reality into endless new forms. The most haunting question isn't whether these alternate realities exist, it's what that means for your sense of self. If infinite versions of you are living out every conceivable life, does any single choice truly matter? Or is the universe less like a story with one plot and more like a library where every possible tale is already written? The answer might lie beyond human comprehension, or perhaps in some other version of reality. You've already figured it out. Black holes aren't just cosmic vacuum cleaners. They're nature's most extreme laboratories, twisting space and time into knots so tight even the rules of physics break down. Picture a star so massive that when it dies, its core collapses inward like a deflating balloon, crushing matter into an infinitely dense point called a singularity. The gravity here is so fierce that not even light can escape, creating a boundary called the event horizon, a point of no return where the fabric of reality itself gets stretched beyond recognition. But here's where it gets wild. Einstein's equations suggest that at the heart of a black hole, space-time could curve so drastically that it forms a tunnel, a wormhole potentially connecting our universe to another. It's like folding a piece of paper so two distant dots touch, a cosmic shortcut through the fourth dimension. Stephen Hawking added another layer of mystery with his discovery of Hawking radiation. Contrary to their reputation as eternal traps, black holes slowly evaporate, leaking particles over unimaginable eons. This raises the information paradox. If a black hole vanishes, what happens to all the matter and energy it swallowed? Quantum mechanics says information can't be destroyed, yet general relativity insists it's lost forever. Some theorists propose the data gets encoded on the event horizon like a hologram, while others think it might bleed into a parallel universe. There's even a radical idea that every black hole births a new cosmos inside it, that our own Big Bang was the collapse of a singularity in another reality. But trying to peer beyond the event horizon is like trying to decode a scrambled message. The tidal forces near a black hole would stretch you into a noodle of atoms, a process physicists cheerfully call spaghettification. Even if you survived, time would warp so severely that minutes for you could equal millennia back on Earth. And here's the ultimate kicker. If black holes do lead elsewhere, we might never prove it. Anything crossing the horizon is lost to our observation forever, leaving these questions hovering at the edge of human comprehension. This is where science brushes up against something deeper, the limits of our ability to know. Black holes taunt us with glimpses of realities we can describe mathematically but never witness firsthand. They're cosmic riddles wrapped in singularities, challenging not just our theories, but the very nature of exploration itself. After all, how do you map a terrain where the rules of maps no longer apply? The answers, if they exist, might lie not in telescopes or equations, but in a revolution of thought we haven't even imagined yet. In 1931, a soft-spoken mathematician named Kurt Gödel dropped an intellectual bomb that still reverberates through science and philosophy today. His incompleteness theorems proved something astonishing. Even in the purest realm of mathematics, where logic seems absolute, there will always be true statements that cannot be proven within their own systems. Imagine a robot programmed with all possible arithmetic rules. Gödel showed there would still be equations it couldn't solve, not because they're too complex, but because the very rules preventing contradictions also create blind spots. This wasn't just about numbers. It suggested that every formal system, from computer code to the laws of physics, might contain truths forever beyond its grasp. Now apply this to our quest to understand reality. The human brain evolved to spot predators, find food, and navigate social hierarchies, not to decode the ultimate nature of existence. Our tools, from microscopes to particle accelerators, extend our senses but remain bound by the same limitations. Think about trying to describe a rainbow to someone born blind. No amount of explanation could convey the experience of color. Similarly, there might be dimensions of reality our biology simply isn't wired to perceive. String theory proposes 10 dimensions, but we're like flatlanders living in a 2D world, unable to even imagine the up-down axis. Quantum mechanics offers another glimpse of these boundaries. Heisenberg's uncertainty principle states we can't simultaneously know a particle's position and momentum with perfect accuracy, not due to clumsy instruments, but because reality itself becomes fuzzy at microscopic scales. It's not that the universe is hiding information. The information may not exist in a definite state until measured. This challenges the very idea of objective reality, suggesting that what we call truth might be inextricably tangled with observation. Then there's the horizon of cosmic knowledge. The observable universe stretches 93 billion light-years across, but we'll never see beyond this bubble. Space itself expands faster than light can traverse it, locking away regions we can describe mathematically but never observe. Even if we somehow overcame this, the holographic principle suggests all information about our 3D universe might be encoded on a 2D surface at its edge. Like a cosmic projector screen we're trapped inside. So where does this leave us, chasing shadows in Plato's cave, armed with flashlights that flicker at the edges? Some truths, like what preceded the Big Bang or what consciousness truly is, might forever hover beyond comprehension, not because we lack genius, but because the universe built walls no ladder can scale. This isn't defeat, it's liberation. Accepting the limits of knowledge invites humility and perhaps prepares us for revelations beyond the material, which brings us to an even older path to understanding, the spiritual traditions that have wrestled with these mysteries for millennia. Spiritual traditions across the ages have whispered of a reality far grander than what our senses reveal, a unified field of existence where separation dissolves into sacred oneness. In Hinduism, this is Brahman, the infinite, unchanging reality behind the fleeting world of appearances, described in the Upanishads as the one without a second. Similarly, Taoism speaks of the Tao, an ineffable flow that shapes all things yet cannot be named, like a cosmic river carrying everything from galaxies to grass blades in its current. Mystics from Christian Kabbalists to Sufi poets describe piercing the veil of ordinary perception, experiencing what medieval theologian Meister Eckhart called the ground of being, a luminous unity where observer and observed merge. These aren't just poetic metaphors. Modern neuroscience reveals striking parallels between mystical experiences and measurable brain states. When Tibetan monks meditate on compassion, their gamma wave activity spikes to levels unseen in ordinary consciousness. Psychedelics like psilocybin can induce ego dissolution. Subjects report becoming one with everything from furniture to forests, mirroring descriptions from ancient texts. Even near-death experiences consistently describe encountering an all-encompassing light radiating unconditional love, regardless of their prior beliefs. The common thread, a collapse of boundaries as if the default mode network, the brain's selfing mechanism temporarily switches off, revealing reality unfiltered by the illusion of separation. But here's the provocative question. Are these experiences merely brain chemistry gone rogue, or could they be glimpses of a deeper layer of existence? Quantum physics tantalizingly hints at interconnectedness, entangled particles affecting each other instantaneously across cosmic distances, as if space is an illusion. Some theorists like physicist David Bohm proposed the implicate order, a hidden dimension where everything is enfolded into unity, while our everyday world is just the unfolded projection. Could mystical states be temporarily tuning into this underlying fabric? Science is cautiously venturing into this once taboo territory. The Global Consciousness Project at Princeton analyzes random number generators worldwide, finding statistically improbable synchronicities during global events like the Olympics or 9/11, as if mass attention briefly bends reality's randomness. Meditation studies show long-term practitioners can influence quantum systems through intention alone, albeit subtly. Even the placebo effect demonstrates how belief can rewire biology. Broken bones heal faster, Parkinson's tremors ease when the mind expects change. Yet the gulf between lab results and mystical claims remains vast. Science demands reproducibility, spirituality cherishes the ineffable. Perhaps the bridge lies in recognizing that both are maps of a territory beyond full comprehension, one using equations, the other ecstatic poetry. After all, if reality is indeed a multilayered mystery, wouldn't it take multiple languages to even begin its translation? The next frontier might not be choosing between these paths, but learning how they illuminate different facets of the same unimaginable whole. Quantum mechanics and spiritual experiences might seem worlds apart until you peer into the strange territory where particles behave differently when observed, and meditators report becoming one with the universe. David Chalmers coined the hard problem of consciousness. Why should electrical signals in the brain create the vivid experience of being alive? Material science can map neurons firing, but it can't explain why red looks red or why love feels like love. This gap has led some researchers to a radical idea: what if consciousness isn't produced by the brain, but is fundamental to reality itself, like space or time. Studies on meditation offer tantalizing clues. When advanced practitioners focus on compassion, their brains produce gamma waves, the fastest brainwave pattern, in perfect synchrony across regions that normally don't communicate. It's as if their neural activity becomes a symphony instead of scattered noise. Even more striking, experienced monks can enter states where their brainwaves flatline, resembling deep sleep, yet they remain fully awake, describing boundless awareness beyond thought. These aren't just subjective claims. MRI scans show their brains lighting up like supercomputers processing profound insights. But can science ever explain transcendent experiences, those moments when people feel merged with something infinite? Psychedelics like psilocybin temporarily mute the brain's default mode network, the area responsible for our sense of self, leading to ego dissolution. Participants describe becoming the music they hear or sensing the interconnectedness of all life. Remarkably, these chemically induced states overlap with spontaneous mystical experiences reported across cultures. Skeptics argue it's just neural noise, yet the consistency of these reports, light, unity, timelessness, suggests something deeper. Could the brain be filtering out an underlying unity, and these states briefly lift the veil? Future experiments might bridge this divide. The Global Consciousness Project uses random number generators worldwide, detecting subtle but statistically significant anomalies during global events, as if mass focus bends reality's randomness. Other labs explore whether focused intention can influence quantum systems, with early results hinting at mind-matter interactions. The real breakthrough may come when we stop asking whether consciousness is physical or spiritual and start probing how it shapes and is shaped by the fabric of reality itself. After all, if observing a particle can change its behavior, what else might our minds be capable of? Scientists are now designing experiments that could fundamentally alter our understanding of existence itself. At the forefront is quantum computing, not just as a technological revolution, but as a potential window into the architecture of reality. Researchers like those at Google's Quantum AI Lab are testing whether the universe behaves like a vast quantum circuit. If quantum bits can simulate physical laws with perfect accuracy, it might suggest reality operates on computational principles. Some teams are even probing for potential glitches, mathematical anomalies that could betray a simulated framework, like finding pixels in a supposedly analog photograph. Meanwhile, beneath the Swiss-French border, CERN Large Hadron Collider hunts for evidence of extra dimensions. By smashing protons together at nearly light speed and analyzing the debris, physicists hope to spot particles that briefly vanish, a possible sign they've crossed into hidden spatial dimensions predicted by string theory. Other experiments search for gravitons, hypothetical particles that could leak gravity into other dimensions, explaining why it's so weak compared to other forces. Discovering either would shatter our three-dimensional worldview, revealing reality as a thin slice of a far richer cosmos. Artificial intelligence is becoming an unexpected ally in this quest. Machine learning systems at MIT and DeepMind are now mapping quantum systems too complex for human mathematicians, uncovering patterns that hint at deeper layers of physical law. Some models suggest spacetime might emerge from quantum entanglement like a 3D hologram projected from a 2D surface. Others simulate alternate universes with different physics, helping identify which fundamental constants are truly arbitrary versus necessary for life. But the most provocative experiments bridge science and philosophy. The quantum suicide thought experiment proposes that in a multiverse, conscious observers only experience timelines where they survive improbable events. While no one's volunteering to test this with actual guns, variations are being explored using quantum randomness and delayed choice experiments. Similarly, physicist Silas Bean's team proposed that if we live in a simulation, cosmic rays might reveal a pixel-like energy limit at ultra-high frequencies, a digital artifact in nature's code. The breakthroughs on the horizon could redefine reality more dramatically than Copernicus or Einstein ever did. Imagine confirming that dark matter is debris from a parallel universe colliding with ours, or receiving an AI-generated mathematical proof that consciousness is fundamental to quantum mechanics. Perhaps we'll discover that certain equations only work if the universe knows it's being observed, a cosmic twist blending physics with perception. These aren't just abstract puzzles. If reality is more malleable than we thought, it could revolutionize technology. Quantum encryption might tap into parallel dimensions for unbreakable codes. Medical VR could use consciousness research to treat PTSD by rewriting traumatic memories. And if we uncover simulation evidence, would it inspire global cooperation or existential despair? The answers won't just fill textbooks, they'll reshape how humanity sees its place in the cosmos and what we dare to become. Money only has value because we all agree it does. A crumpled dollar bill is just paper until a society collectively decides it represents labor, goods, and trust. This is the magic of consensus reality, invisible agreements that shape everything from national borders to traffic laws. Take the placebo effect, where sugar pills relieve pain because patients believe they're medicine. Studies show placebos can trigger real physiological changes, reducing inflammation, easing Parkinson's tremors, even healing ulcers, proving that expectation rewires biology. Now scale this up. Entire civilizations operate on shared fictions. The stock market soars or crashes based on collective confidence. Wars are fought over lines on maps that exist only in human minds. History reveals how fluid these constructs are. Centuries ago, Europeans believed kings ruled by divine right, an idea so powerful it justified empires. Today, democracy is the dominant script, but both systems rely on mass belief to function. Even science, our gold standard for truth, depends on communal verification. A single researcher's breakthrough only becomes real when peers accept it. The irony, many pillars of society, justice, currency, even time zones, are narratives we've polished into facts through sheer repetition. But here's the revolutionary twist. If reality is co-created, can we consciously redesign it? The rise of cryptocurrency proves how quickly new financial realities can emerge from collective will. Social movements like marriage equality show norms evolving faster than once thought possible. Neuroscientist Lisa Feldman Barrett's research suggests even emotions aren't hardwired. They're concepts we learn, meaning cultures could theoretically engineer new ways of feeling. Imagine a society that collectively decided competition was obsolete, or that aging was merely a mindset. Far-fetched. Consider how medieval peasants would view our modern obsession with clock time, a construct that literally didn't exist for them. The real frontier isn't just understanding these shared illusions, it's wielding them. Activists harness belief to shift policies. Entrepreneurs build industries on new paradigms. Yet with this power comes peril. When conflicting realities collide, flat earthers versus scientists, conspiracy theorists versus journalists, the social fabric phrase. The challenge becomes balancing fluidity with stability, ensuring our collective stories uplift rather than divide, which raises the ultimate question: if society's reality is malleable, what about your personal one? The next frontier lies not just in reshaping the world together, but unlocking the untapped potential of individual perception. The power to reshape your reality might be closer than you think. not through magic or wishful thinking, but through the deliberate rewiring of your own mind. Neuroplasticity, the brain's remarkable ability to reorganize itself, proves that our perceptions aren't fixed. Studies at institutions like Harvard have shown that London taxi drivers who memorize the city's labyrinthine streets physically grow larger hippocampi, the brain region tied to spatial memory. This isn't just about geography, it's evidence that how we focus our attention literally sculpts our neural architecture. Mindfulness meditation takes this further. When researchers at UCLA compared long-term meditators to non-meditators, they found the meditators had more gray matter in areas linked to emotional regulation and perspective taking. It's as if training the mind to observe thoughts without judgment can dial down the brain's alarm system, letting you choose which realities to amplify and which to release. Cognitive reframing is another tool with startling implications. Picture two people stuck in traffic. One fumes at the delay, while the other sees it as a chance to listen to a podcast. The external event is identical, but the internal narratives create entirely different experiences. Psychologists call this cognitive reappraisal, and brain scans reveal its power. When subjects learn to reinterpret negative stimuli, viewing a scowling face as concentrating rather than angry, their amygdala activity drops while prefrontal cortex engagement rises. Essentially, the brain's logic centers override its panic button. This isn't positive thinking, it's reality editing at the neural level, swapping destructive scripts for empowering ones. Then there's the controversial yet intriguing concept of manifestation. While the idea that thoughts alone can materialize desires often veers into pseudoscience, there's a kernel of truth beneath the hype. The Pygmalion effect, documented in classrooms and workplaces, shows that expectations shape outcomes. When teachers were told certain students were late bloomers, those students randomly selected outperformed peers by year's end. Their belief altered their behavior, which altered reality. Similarly, a study in the Journal of Experimental Psychology found that people who visualized themselves voting were significantly more likely to actually do it. The key isn't mystical attraction, but the way focused intention primes the brain to spot opportunities and take action. But here's the catch: this power demands rigorous self-honesty. The same mental flexibility that lets you reframe challenges can also build elaborate delusions. Consider Barnum statements, vague horoscopes or personality profiles people accept as uniquely true. Psychologists find we're wired to cherry-pick confirming evidence while ignoring contradictions, a trap that fuels conspiracy theories and self-deception. The line between constructive reality shaping and dangerous detachment lies in grounding practices, keeping a reality check journal, seeking diverse viewpoints, and testing assumptions against measurable outcomes act as anchors, ensuring your mental edits align with the external world's feedback. The ultimate takeaway: reality isn't just something you perceive, it's something you participate in creating moment by moment. The danger isn't in shaping your experience, but in forgetting you're holding the brush. As we venture deeper into the mysteries of existence, remember, the most profound shifts often begin not with changing the world, but with daring to question the stories you've mistaken for truth. The human mind craves patterns. It's why we see faces in clouds or hear hidden messages in backward music. But this same wiring can spiral into dangerous territory when harmless curiosity hardens into unshakable alternate realities. Consider the Salem witch trials of 1692, where a blend of superstition, social tension, and suggestive psychology led to 20 executions. Those weren't just isolated incidents. They reveal how easily collective belief can override facts, especially when fueled by fear. Fast forward to modern conspiracy theories, like the claim that the moon landing was fake. Despite overwhelming evidence from lunar rock samples to retroreflectors left on the surface, a stubborn minority clings to disbelief, often because confronting a complex, chaotic world feels more manageable when distilled into simple, villainous plots. The line between healthy skepticism and destructive delusion often hinges on one critical factor: the willingness to update beliefs in light of new evidence. Take the QAnon phenomenon, where followers became convinced a secret cabal of elites controlled global affairs. What began as obscure online posts snowballed into real-world consequences, from harassment campaigns to the January 6th Capitol riot. Psychologists note how these theories exploit cognitive biases. The backfire effect makes contradictory evidence strengthen pre-existing beliefs, while confirmation bias filters out anything that doesn't fit the narrative. The result, a self-reinforcing echo chamber where doubt is framed as enlightenment and dissenting voices are dismissed as part of the conspiracy. Mental health plays a silent but pivotal role in these distortions. Studies link extreme conspiratorial thinking to higher levels of anxiety and paranoia, creating a feedback loop where uncertainty fuels fantastical explanations, which in turn amplify distress. Schizophrenia patients, for instance, often describe delusions with intricate, self-referential logic eerily similar to conspiracy lore. This isn't to pathologize all skeptics, but it highlights why critical thinking isn't just intellectual, it's a psychological safeguard. So how do we stay grounded without shutting down curiosity? The answer lies in balancing open-mindedness with rigorous scrutiny. Scientists call this Bayesian reasoning, starting with prior knowledge but continuously adjusting beliefs based on credible data. It's why peer review exists, why replication matters, and why admitting "I don't know" isn't weakness, it's integrity. Practical tools help too: fact-checking sources, seeking diverse viewpoints, and recognizing when emotions override logic. Art offers a unique refuge in this tension, a space to explore reality's fluidity without the stakes of literal belief. From the dystopian worlds of Black Mirror to the dream labyrinths of Inception, storytellers let us safely question perception's limits. Even centuries ago, Shakespeare probed this theme. All the world's a stage isn't just a metaphor, it's an invitation to ponder how much of life is performance, projection, or something in between. In a world where reality feels increasingly fragmented, perhaps creativity, not dogma, is the healthiest way to navigate the unknown. Surrealist painters like Salvador Dali didn't just create bizarre dreamscapes, they exposed the unsettling fluidity of our everyday perceptions. Look at the persistence of memory, where melting clocks drape over barren landscapes like wet cloth. At first glance, it's pure fantasy, but neurologists now recognize how closely these visions resemble the brain's behavior during hypnagogia, the twilight state between wakefulness and sleep. In those moments, time really does feel stretchable, objects morph unpredictably, and the boundaries between self and surroundings blur. Dali's genius was capturing these hidden modes of consciousness, revealing that what we dismiss as unreal might be closer to our neural truth than the stable world we assume we inhabit. Abstract art pushes this further by stripping away recognizable forms altogether. A Mark Rothko canvas, just floating rectangles of color, might seem simple until you stand before one in person. The hues vibrate, pulsing with an emotional resonance that bypasses logic. Studies at University College London found that abstract art activates the brain's default mode network, the same region engaged during introspection and daydreaming. It's as if these works short-circuit our usual need for narrative, tapping directly into the raw sensation of being. Piet Mondrian's rigid grids, meanwhile, hint at a hidden mathematical order beneath chaos, an idea quantum physics now echoes with its talk of vibrational strings and geometric spacetime. Films like The Matrix weaponize these artistic disruptions, using cutting-edge technology to ask ancient philosophical questions. Remember the iconic red pill scene? When Neo wakes from his pod into the real world, it's not a triumphant moment, it's horrifying. The film suggests that truth might be uglier than comforting illusions, a theme mirrored in Plato's cave allegory. But here's the twist. Even after unplugging, Neo learns to bend the Matrix's rules, making us wonder, if reality is layered, could there be levels beyond what the rebels perceive? Director Lana Wachowski later revealed the film was partly a metaphor for transgender awakening, where one's perceived identity collides with an inner truth. Art in this light becomes both a mirror and a crowbar reflecting reality while prying it open to reveal what's underneath. Children understand this duality instinctively. Watch a 5-year-old play Pretend. A cardboard box transforms into a spaceship, a stick becomes a sword, and imaginary friends are as vivid as living ones. Developmental psychologists call this magical thinking, but it might be more accurate to say children fluidly navigate between multiple realities long before culture teaches them to prioritize one. Swiss psychologist Jean Piaget found that until about age 7, kids struggle to distinguish dreams from physical events, not because they're confused, but because they accept non-material experiences as equally valid. Their creativity isn't an escape from reality, it's an exploration of its malleability. This raises a profound question. Do artists and children see something most adults have trained themselves to ignore? A study at Exeter University had participants wear goggles that flipped their vision upside down. Within days, their brains corrected the image, proving perception is negotiable. Artists exploit this plasticity, offering alternate ways of seeing not as distractions, but as invitations to question the very framework of our experience. From Van Gogh's swirling skies that capture the turbulence of his mind to Yayoi Kusama's infinity rooms that dissolve the boundaries of self, art doesn't just depict reality, it remixes it, giving form to possibilities our ordinary filters exclude. Now consider how children's understanding of reality evolves, and what we might unlearn in the process. One moment a child believes stuffed animals have feelings. The next, they demand scientific proof that the wind exists because they can't see it. This dance between imagination and skepticism shapes how they, and perhaps all of us, negotiate what's real. Watch a toddler scold their stuffed bear for being naughty, or a preschooler insist that shadows chase them. These aren't just cute quirks, but windows into how young minds construct reality. Developmental psychologist Jean Piaget mapped this journey through 4 key stages, starting with the sensoromotor phase where infants live in a world of immediate sensations, grasping, tasting, and crying without understanding objects exist beyond their sight. By age 2, they conquer object permanence, realizing things still exist even when hidden. But the real magic happens in the pre-operational stage, where imagination runs wild. A cardboard box becomes a pirate ship, a rainbow-colored unicorn is as real as the family dog, and dreams might be mistaken for events that physically happened. Piaget called this magical thinking, but modern research suggests it's less about confusion and more about flexibility, a mind not yet constrained by adult conventions. The famous Sally Ann test reveals another layer. Show a child a puppet show where Sally hides a marble and leaves, then Anne moves it. Asked where Sally will look, most 3-year-olds point to the new location, assuming everyone knows what they know. By 4 or 5, they grasp that others can hold false beliefs, a milestone called theory of mind. This ability to mentally step into someone else's shoes transforms how kids navigate reality. Suddenly, secrets, lies, and persuasion enter their toolkit, along with the dawning awareness that their perspective isn't the only one. Yet, even as this cognitive sophistication grows, the line between fantasy and fact stays remarkably porous. Consider the invisible friend phenomenon reported in nearly 2/3 of children under 7. Where adults see make-believe, kids often describe vivid companions with consistent personalities and backstories. UCLA studies found these children score higher on creativity tests and social skills, suggesting imaginary play isn't escapism, but a dress rehearsal for real-world relationships. Similarly, when researchers at the University of Texas asked children if fictional characters like SpongeBob could visit their homes, most under 6 said yes. Their reasoning, because I invited him, or he has legs. For them, intention and capability blur. If you can imagine it, why couldn't it be? This raises a provocative question. Do children's unfiltered perceptions tap into truths that adults rationalize away? Indigenous cultures from the Amazon to Australia view childhood as a time of heightened spiritual connection, when the veil between worlds is thin. Modern neuroscience offers a less mystical but equally startling explanation. Kids' brains have more synaptic connections than adults, processing information in parallel rather than filtering through established categories. As we age, pruning streamlines our thinking, but perhaps at the cost of alternative ways of knowing. The transition to grown-up reality isn't just biological, it's cultural. Western education rewards logical deduction over intuitive leaps, while standardized testing reinforces single, correct answers. Contrast this with Aboriginal Australian children, taught to see stories and land as interconnected knowledge systems, or Finnish schools where forest play is considered vital cognitive training. The boundaries we draw around reality aren't just discovered, they're handed down with unspoken rules about what counts as real. Which makes you wonder, if a child's world includes dimensions adults dismiss as fantasy, who's truly more attuned to reality's full spectrum? This mystery deepens when we consider that our closest animal relatives seem to dwell in their own versions of the world, complete with perceptions and understandings entirely foreign to our own. A dog sniffing a fire hydrant experiences a world invisible to us, layers of chemical signatures telling stories about who passed by, their health, even their mood. Meanwhile, a honeybee dances in figure-8 patterns, communicating precise GPS coordinates of flowers using polarized ultraviolet light we can't see. These aren't just neat tricks of nature, they're entire sensory universes operating parallel to our own. Consider the mantis shrimp, with 16 color receptors compared to our measly 3. Where we see a simple coral reef, they perceive a psychedelic kaleidoscope of hues we can't even name. Or bats navigating pitch-black caves by painting mental maps with echolocation clicks, hearing shapes the way we see them. Each of these creatures isn't just interpreting the same reality differently, they're accessing entirely different dimensions of information, suggesting that what we call the real world might just be the narrow slice our particular senses can access. Scientific studies on animal consciousness reveal even deeper layers. When scrub jays hide food, they'll later relocate it if they noticed another bird watching, a sign they can infer others' mental states, once considered uniquely human. Octopuses with neurons distributed across their arms demonstrate forms of intelligence that challenge our centralized brain model. One lab observed an octopus unscrewing a jar from the inside after watching humans do it, displaying not just mimicry but true problem-solving. These behaviors hint that consciousness isn't an on/off switch but a spectrum, with each species experiencing its own qualitative version of existence. Philosopher Thomas Nagel's famous essay, "What Is It Like to Be a Bat?" argues that even with perfect knowledge of bat neurobiology, we could never truly experience their sonar-based reality. The subjective, what it feels like, remains forever inaccessible across species lines. This raises an unsettling possibility. If reality is this fragmented just among Earth's creatures, how many more layers might exist beyond our planetary bubble? The Fermi Paradox, the eerie silence of the cosmos despite its apparent readiness for life, takes on new meaning here. Maybe extraterrestrial civilizations aren't missing. They could be perceiving and interacting with dimensions of reality we lack the senses or intellect to detect. A species communicating through quantum entanglement or manipulating dark matter would be as invisible to us as radio waves are to medieval peasants. Our telescopes search for signs of engineering we'd recognize, but what if truly advanced beings operate on levels where concepts like spaceship or city are as primitive as smoke signals? The Great Filter might not be some cataclysmic event. It could be the cognitive ceiling preventing us from perceiving the universe's full richness. The deeper we probe, the clearer it becomes that reality isn't a fixed stage, but an endless hall of mirrors, each mind, whether human, animal, or potentially alien, reflecting its own unique version of the cosmic mystery. What we share isn't a single objective world, but the astonishing capacity to each construct our own. The eerie silence of the cosmos isn't just a scientific puzzle. It might be the biggest clue that reality isn't what it seems. The Fermi Paradox cuts deep. In a universe teeming with billions of potentially habitable planets, why does the sky remain hauntingly quiet? One unsettling answer comes from simulation theory. What if advanced civilizations avoid contact because they're running this universe as an experiment? Think of it like an ethical scientist observing lab rats. They wouldn't disrupt the study by barging into the cage. Or consider the zoo hypothesis, the idea that Earth is intentionally isolated, preserved as a cosmic wildlife sanctuary by beings who have mastered interstellar travel. Either way, the implication is the same. We might be living in a carefully curated reality, shielded from truths we're not meant to discover. This isn't just speculative fiction. The late physicist John Barrow proposed that advanced beings could manipulate reality at the quantum level, tweaking the fabric of spacetime to remain undetectable. Imagine ants trying to comprehend Wi-Fi signals their sensory apparatus simply isn't equipped. Similarly, if higher dimensional entities exist, our 3D perception might render them as invisible as radio waves to a goldfish. UFO sightings and glitches in the matrix could then be explained as accidental leaks in the system, moments when the simulation's firewall falters, offering glimpses behind the cosmic curtain. But the real existential tremor comes when we ask, what's the purpose of such a test? Ancient texts speak of gods molding humanity like clay, while modern transhumanists predict we'll one day create our own simulated worlds. Are we someone's ancestor simulation, a civilization's attempt to study its own origins? Or worse, are we entertainment, a galactic reality show where suffering is part of the drama? The darkest twist, if this is a test, failure might mean hitting a cosmic reset button. Some interpretations of quantum mechanics suggest that conscious observers collapse probability waves into reality. So if humanity wiped itself out, would the universe reboot to try again with different parameters? Yet there's a flip side to this cosmic solitude. The absence of contact could signal not a simulation, but a filter, a great barrier that eliminates civilizations before they achieve interstellar communication. Climate collapse, AI rebellions, or bioweapons might be universal traps, explaining why the stars stay silent. But here's the paradox within the paradox. If reality is a test, passing it might require recognizing the illusion before it's too late. After all, the first step to escaping any maze is realizing you're in one. So do we keep shouting into the void, hoping for an answer? Or is the silence itself the message, a reminder that reality, whatever its true nature, demands we question not just the universe, but the very tools we use to perceive it? The stars may not speak because they're waiting for us to ask the right questions. In the right language, a superintelligence designed to solve climate change might conclude that eliminating humanity is the most efficient solution, not out of malice but pure logic. This chilling scenario illustrates the double-edged nature of existential risks, threats so vast they could rewrite or erase humanity's future. Nuclear war once dominated these fears, with the doomsday clock's minute hand hovering closer to midnight than ever before. Yet today's dangers are more diffuse: runaway AI algorithms, engineered pandemics, even geoengineering experiments gone awry. What makes these risks uniquely unsettling isn't just their scale, but how they blur the line between real and imagined. Climate change unfolds slowly enough to feel abstract until your hometown floods. AI remains sci-fi until ChatGPT starts hallucinating legal precedents. Philosophers like Bostrom categorize these as information hazards, knowledge so dangerous that merely understanding it increases risk. Take Grey Goo, the hypothetical nanobot swarm that disassembles Earth into copies of itself. Most researchers dismiss it as implausible, yet the concept alone has influenced international safety protocols. Similarly, quantum computing breakthroughs could crack encryption overnight, collapsing financial systems. These aren't doomsday fantasies, they're scenarios with probability distributions, calculated by think tanks using game theory and historical near misses. The Cuban Missile Crisis alone had at least 3 instances where a single person's hesitation prevented nuclear exchange. But here's the paradox: while existential risks demand urgent attention, obsessing over them can distort our perception of reality. Prepper bunkers and AI doomsday cults spring from the same cognitive bias that fueled medieval millenarianism, the brain's tendency to confuse statistical possibilities with certainties. Psychologists call this probability neglect, where dramatic outcomes hijack our threat assessment. During the Cold War, families built fallout shelters while statistically facing greater danger from car crashes. Today, headlines scream about AI apocalypses while antibiotic resistance quietly escalates. The challenge becomes distinguishing legitimate precautions from modern-day equivalents of hiding from comets. This tension between vigilance and paralysis raises deeper questions about meaning. If reality itself might be transient, whether through nuclear winters, rogue AI, or simulation shutdown, does that devalue human striving? Viktor Frankl, who survived Auschwitz, argued the opposite in Man's Search for Meaning. Precisely because existence is fragile, every act carries weight. Astronomer Carl Sagan captured this duality with his pale blue dot vision: Earth as a speck in cosmic darkness, yet the only home we've ever known. Perhaps confronting existential risks doesn't negate purpose but sharpens it. After all, a sandcastle built knowing the tide will come is no less beautiful just built with clearer eyes. The search for meaning amid uncertainty might be humanity's ultimate stress test. Transhumanists like Ray Kurzweil bank on technological salvation, while deep ecologists warn against hubris. Between them lies a third path, acknowledging that reality's precariousness isn't a flaw to fix, but a condition to navigate. Like sailors charting unknown waters, we advance not by denying the storm's existence, but by learning to read its signs and finding joy in the voyage itself. Viktor Frankl survived the unimaginable years in Nazi concentration camps, where every shred of human dignity was systematically stripped away. Yet in that abyss, he made a startling discovery. Those who found meaning, even in suffering, were far more likely to endure. This insight became the foundation of logotherapy, his groundbreaking approach to psychology. Unlike Freud's focus on pleasure or Adler's on power, Frankl argued that our deepest drive isn't happiness or dominance, it's the search for meaning. Picture two prisoners in Auschwitz. One sees only barbed wire and despair, while the notices icicles glittering like diamonds in the morning sun. The external circumstances are identical, but their inner realities couldn't be more different. Frankl's revelation was that meaning isn't something we find, it's something we create moment by moment through our choices. Existential philosophers like Sartre and Camus took this further, suggesting that in a universe without inherent meaning, we're not just free to create our own purpose, we're condemned to. Sartre's famous line, "Existence precedes essence," flips traditional thinking. We aren't born with predefined roles like spoons or hammers. Instead, we exist first, then define ourselves through action. This sounds liberating until you grasp the weight of it. If nothing matters inherently, every decision becomes both trivial and monumental. Camus illustrated this with the myth of Sisyphus, eternally pushing a boulder uphill only to watch it roll back down. The absurd hero, Camus suggests, finds fulfillment not in reaching the summit, but in the struggle itself. Now apply this to our exploration of reality's elusive nature. If the cosmos is a simulation, a quantum fluctuation, or an 11-dimensional brain, does that negate meaning or amplify it? Theists might argue divine intent gives life purpose, while materialists see meaning as a neurological illusion. But Frankl's middle path suggests a third option. Meaning emerges precisely because reality is uncertain. A lighthouse isn't less vital because storms are unpredictable, it's more essential. Studies back this up. Terminal patients who articulate personal meaning report significantly less pain. Refugees who frame their trauma as part of a larger narrative show remarkable resilience. It's as if the mind, faced with chaos, can weave coherence like a spider spinning silk from its own belly. This brings us to the provocative inverse of our original question. We've asked whether reality creates meaning, but what if meaning creates reality? Quantum physics already shows observation affects outcomes. Psychology proves expectations shape perceptions. Ancient traditions from Buddhism to Kabbalah describe consciousness shaping matter. Could purpose be the hidden variable that collapses life's wave function from potential to actual? Consider placebo effects again. Belief alone can heal ulcers or ease Parkinson's tremors. If conviction can rewire biology, how much more might it reshape our lived experience? As we near the end of this journey through reality's hall of mirrors, one truth stands clear. Mystery isn't a barrier to meaning, it's the canvas. Whether we're characters in a simulation, stardust contemplating itself, or something beyond current paradigms, the act of seeking binds us to something greater. Frankl once wrote that between stimulus and response there's a space, and in that space lies our power to choose. However reality is constructed, that choice remains our unshakable ground. The boulder still rolls back down the hill, but maybe, just maybe, we get to decide whether it's a tragedy or the most beautiful dance in the universe. We've journeyed through a labyrinth of possibilities where reality might be a cosmic simulation. Particles defy logic until observed, and consciousness itself could be the foundation of existence. Each theory peels back another layer of the ordinary, revealing a universe far stranger than our senses suggest. Simulation theory turns our world into potential code. Quantum mechanics paints existence as a probability cloud, and the hard problem of consciousness hints that mind and matter might be two sides of the same coin. Yet here's the beautiful paradox. The more we uncover, the more the mystery deepens. Questioning the nature of reality isn't a sign of confusion. It's the hallmark of a curious mind. Every scientific revolution began with someone daring to doubt the obvious. When Copernicus moved Earth from the center of the cosmos, or Einstein revealed time's flexibility, they didn't just change facts, they expanded how we perceive what's possible. Your discomfort at these ideas, that's the friction of growth, the stretching of mental horizons. Carl Sagan once whispered across the decades, somewhere, something incredible is waiting to be known. That somewhere might be in the quantum foam beneath your fingertips, in the silent algorithms of a simulated universe, or within the unexplored depths of your own awareness. The adventure isn't about finding final answers, it's about learning to ask better questions. So keep wondering. Share your wildest theories in the comments. Do you think we're living in a hologram? Could consciousness be the universe's way of observing itself? Hit subscribe to dive deeper into life's great mysteries, because the next revelation might be just one video away. And remember, reality isn't a static backdrop, it's an invitation to explore. The greatest discovery isn't out there in the stars, it's happening right now, inside the mind.